Hi everybody, welcome back once again to this channel. Thank you very much for joining us once again. Today we're going to look at this question from 2024 trial exam from your Kwazulu Natal province. It's a calculus question. This was question 8. Okay. Someone said they struggle a lot with it, so we just want to explain it and see how it goes. If you're new to the channel, please make sure you're subscribed. Just turn on that notification bell so that you can be notified every time when we upload a new session. Without wasting any time, let's get into it. Okay, so this was question 8, and we're given that the graphs of f of x equals to x minus 1 squared, x plus n, and g of x equals to 1 over 2x plus 2 are drawn, right? And we are told that p and q, as you can see in the diagram here, are the x-intercept of f, and you have p and s as the turning points of f, and g passing through q. Okay. So the first question, 8.1, wants us to calculate the coordinates of what? Of Q. So if you check Q there, let me use a black color. If you check Q, is the x-intercept of F, and it's also the x-intercept of G, right? But we cannot use the equation of F because in this case it has some unknowns such as n. So obviously we're gonna go and find the x-intercept of G, because also Q is the x-intercept of G. So by letting y to be equals to 0, then we have 0 equals to minus 1 over 2x plus 2, and we can take minus 1 over 2 to the other side. It will be positive 1 over 2x equals to 2. To solve for x, multiply both sides by what? By 2. So then finally x will be equals to 4. Then coordinate of Q will be 4 and what? 4 and 0. As you can see, that will be 4 and 0 there. Okay, let's go to 8.2. So in 8.2, they said hence write down the value of n. So the word hence means the answer we got in the previous question must assist us to get the answer in that current question, right? So 8.2, if they're saying hence calculate the value of n, if you can check, n is on the function of f. Can you see? So obviously in that function you can see that if I need the x-intercept, we let y to be 0, so another x-intercept will be x equals to 1, which is obviously at p there, right? Then obviously the other one has to be 4. It means that we'll have another factor there as what? As x minus 4, so that when you equate it to 0, you get x equals to 4. Can you see? Then we can deduce that n will be equals to what? Negative what? Negative 4. Okay, let's go to 8.3 now. So in 8.3, they want us to calculate the length of PQ from P to Q. Okay, so obviously from P to Q, it's a vertical line. It's a horizontal line. Can you see? And if you check, it's on the x-axis, right? What we can do is that, okay, PQ, we can just take x at what? SQ minus x at P. Then it will give us that distance there. X at Q, it is 4, minus x at P, it is 1. So PQ will be what? 3 units. Okay, let's go to 8.4 now. So 8.4, it says calculate the coordinate of S, right? If you check S, it's actually the turning point of F, right? Of your cubic function. So obviously to get the X at the turning point, what do? We can go and find the equation, derive it, equate it to 0, because we know that at the turning point, the first derivative will equals to what? Will be equals to 0. Okay, so that's what we're gonna do. We are going to first find the equation. The equation is x minus 1 squared, and we have n, which is minus 4, so it's x minus 4. So obviously we'll start by simplifying this. So this will be x squared minus 2x plus 1 being multiplied with x minus 4, right? So x times x squared, x cubed, minus 2x times x minus 2x squared. 1 times x, it's going to be x, right? Minus 4 times x squared minus 4x squared minus 4 times minus 2x, it's going to be positive 8x. Minus 4 times 1, it's going to be minus 4. Then we can simplify this equation to say f of x is equals to x cubed. We can add like terms, minus 2x squared minus 4x squared is going to be minus 6x squared. Then x plus 8x is going to be plus 9x minus 4. Then when our equation is like this, we can now go and find what? The first derivative. We derivate, it's going to be 3x squared minus 12x plus 9. This is equated to what? To 0, because our first derivative must be equals to 0 as we are trying to solve for those turning points, right? I'm just going to delete this side, or maybe I can write it on top. So we have like 3x squared minus 12x plus 9 equals to 0. If I take 3 as the common factor, I have x squared minus 4x plus 3 is equals to 0. Right? Divide by 3, 3 will go away. Then you factorize this. X, 3 and 3. 3 and 1. Those are the factors. When we add them, they must give us minus 4. So it must be minus 3 and minus 1. That will give us minus 4. Then we know x is equals to 3 or x is equals to 1. And you can see that the x equals to 1, it's for p, right? It's there at p, where we already saw that x equals to 1. So obviously for at s, x must be what? Must be 1. But to get to y, we go back to our equation, we substitute x equals to 1 and see how much we get for y, right? So if we substitute 1 where there is x, 1 minus 1 squared, 1 minus 4. Okay, so our f of at 1, oops, I think there's a slight mistake. Obviously at s, because x equals to 1, remember here guys, x equals to 1, it's for p. So for s, this is 3, right? So we're gonna substitute 3. Remember at p, x is 1, so the other turning point here, it's where x equals to 3. Okay, I just made a slight mistake there. Then you substitute 3 where there is x. We substitute 3, we substitute 3, right? Then we can get our answer of the y coordinate, which is going to be equals to minus 4. Then we can know the coordinate of s. It's going to be 3 and minus 4. Okay, let us now go to 8.5. 8.5 wants us to describe the concavity of f at x is equals to 0. So if you check when x is 0, let me use a highlighter, or maybe this point, it's here, right? When x is 0, it's there at the intersection of the x-axis there, right? It's basically on the y-intercept there. So if you check the graph, when x equals to 0 at that point, we can see that the graph was concave what? It was actually concave down. All right. So our answer is going to be what? Concave down. Okay. Let us now go to 8.6. Okay, 8.6 it says given h of x equals to minus 1 over 2x plus x. Plus k, right? For which values of x will h be a tangent to f? Alright? For which values of x will this be now a tangent to f? Okay, so what we have to do first is we need to understand that if this graph h be a tangent to f, that is the gradient of this function is the same as the first derivative of f. Do you understand? So remember, the first derivative and the gradient is the same. Then we can use that idea to solve for those values of x where that function is actually a tangent. Okay, so if h is a tangent to f, then its gradient, I'm saying the gradient of h of x will be the same as the first derivative of f of x, right? So that is it, and you can use that idea to go and solve for x, right? So remember, we had found the first derivative somewhere when we were finding the coordinate of s, right, in 8.4. Let me just rewrite that equation. So the equation was 3x squared minus 12x plus 9, right? The one for the first derivative. Okay. Then the gradient of h, we can see on that equation, the gradient there, it's half, negative half, right? So minus 1 over 2. So obviously for that one to be a tangent here, that is, its gradient must be the same as the first derivative. Then you can now see that we can now go and actually solve those values of x that will ensure that that h is actually a what? A tangent. Can you see? So obviously you can take this to the other side, so you'll have 3x squared minus 12x plus 9 plus 1 over 2, right? Because it's going to the other side. This is equated to 0. So you have 9 plus 1 over 2, which will give you 19 over 2. So I can replace this with what? 19 over 2. Then you don't need to stress yourself. You can just go and use your quadratic formula, to solve for x, right? So x equals to minus b plus or minus root of b squared minus 4ac divided by 2a, right? We don't really have space, but I'm just gonna put it on top. Then we have like x is equals to minus, your b is negative 12 plus or minus the root of b is minus 12 squared minus 4, a is 3, c is 19 over 2 divided by 2 into a, which is 3. Then you can just simply punch this on your calculator and finally solve those values of x. So the values of x will be x equals to 2.91 or x is equals to, when you use your calculator on your quadratic formula, x will be equals to, let me check again. It's going to be x is equals to 1.08. Okay, so those will be the values of x that will ensure that h is actually a tangent to f. All right, I hope you find this helpful. Don't forget to like, share, comment, and subscribe. See you soon. Bye.